This is Antonio Ponzo presenting time comparison between Java and C++ using a simple stack program. So first, to start off, I want to talk about why Java and C++ were chosen for this experiment. As it is known, runtime is critical in any programming language. Java and C++ are two of the most used languages, and these languages are often compared with regard to speed of execution and runtime. In this study, a simple stack program is used to compare the runtimes of Java and C++. So, some background information. What is a stack? A stack is a sequential data structure, or a limited access data structure. It's a container of objects that are inserted and removed in a last in, first out manner. A stack has two operators, the push operator, which places items into the stack, and the pop operator, which removes items from the stack. Stacks can be implemented in various ways, and they are useful for searching and sorting data. Stacks are also commonly used as a means of allocating and accessing memory. To discuss experimental design for this research, as I mentioned earlier, a simple stack program was written in both C++ and Java. The program for this experiment only utilized the push and pop methods. Each trial for the experiment consisted of 3 runs. A run was performed by pushing or popping varying numbers of elements onto or off of the stack. The elements pushed onto the stack were integers of varying amounts. The first trial was integers 0 through 99,999. The second trial was a million integers, 0 through 999,999. The third trial was 5 million. The fourth trial was 10 million. At the end of the runs, the average of the 3 runs were recorded for each trial. In this experiment, runtime was measured using the internal clock method available in each language. The programs were run on a Linux system, with the Java program being run using Eclipse IDE Mars version 4.5. To create the graphs, RStudio was used, version 3.2.2. In this slide, you can see an example of the stack implementation in C++. As you can see, you create a main method, you call the stack, we use a for loop in order to push objects or the integers onto the stack, and we use the struct timeVal in order to get the runtime of the program. In this slide, you can see the R script for creating the graphs that will be shown in later slides. The graph was created by importing a text file with the data. Then each variable was stored into a variable name, as in java2 equals java underscore run $Java. These variables were plotted, and each graph was distinguished by a color and either a solid line or a dashed line. As you can see in this slide, the table represents the raw data for each trial for Java and C++ for the varying number of elements pushed onto the stack. Also on this slide, you can see the graph representing the data. In this graph, you can see that although Java and C++ exhibit similar runtimes in the early trials, trial 1 and 2, the time difference in trial 3 and trial 4 are significantly different. As you can see from the graph, C++ has very little change in the runtime from trial 1 to trial 3, or from the first run to the last run. However, the difference in Java from the 100,000 number of elements to the 10 million is significant. You can also see that the difference between Java and C++ in the larger number of elements is vastly increased, with C++ being the obvious faster of the two programs. In conclusion, the graph and the data collected showed that C++ has a quicker runtime than Java at large numbers of elements pushed onto the stack, i.e. greater than or equal to 5 million. The average time for push and pop data was identical, so pop data was excluded from this report. Some possible reasons for the difference between Java and C++, or reasons that C++ was significantly faster than Java when the number of integers pushed onto the stack got larger, could be attributed to several things. One thing is Java has managed memory. With managed memory, Java implements garbage collection. The Java virtual machine is responsible for this garbage collection. Although this helps programmers avoid memory leaks that would be difficult to catch in C++, it also could lead to what are called freezes, in which the garbage collection freezes the program to free up resources. During a freeze, the program stops, which could have led to slowing down of the program in Java versus that in C++. Another possible reason for the difference is that Java must compile through a virtual machine. This virtual machine helps manage the memory. However, it also adds extra steps with the compiling, which could lead to runtime penalties, causing Java to be slower than C++. On this slide, we have our references and additional resources that may be looked at for future viewing. In conclusion, it can be seen from this study that a program that may need to use large amounts of data in a stack or need to utilize large amounts of memory allocation would run faster if programmed in C++. Thank you.